In the last video I showed you how I motorized my EQ5 mount. The one before that, how I made my OnStep telescope controller. Now we need to get into flashing. That is the configuration and upload of firmware onto the telescope controller. Anyway, I'm Nugsy, this is Cheapass-tro, and this is part 3 of the OnStep series. So we've motorized the mount, and we've built the telescope controller. Now this video is going to be about everything else you need to get this thing working. Because at the moment the boards on this controller have no firmware on it, no instructions whatsoever, it hasn't got a clue what to do. Now when building the controller we were following, or I was following, these instructions. And as we scroll past the actual building of the thing, we get onto the flashing firmware instructions. Now this does look an absolute nightmare to the uninitiated, and I was one of those, and this is why I've made this video. I know these videos aren't the most entertaining, they're not the best for the channel, but they're there for the community, for the long term. This video is not a step-by-step, you must do this, you must do that guide. It is no substitute for the OnStep wiki pages. This isn't a accompanying video, just to take the sting out of it a little bit and help to understand what's going on. So we're going to go through step by step with the configuration and the actual flashing of the firmware, and also the adjustment for the stepper drivers. We haven't done that yet. So we're going to start off by just checking the next thing on the list we were working on when building the OnStep controller. And this next instruction says that the following is extracted from this link. Link is also in the description below. It's instructions for uploading and configuring firmware to the finished Max ESP3 controller. If you're using a different controller, then you're going to have to be following your own wiki pages on this, because certain steps will differ. But still, a lot of this will apply for any of the OnSteps that you're building. But remember, don't treat this as a guide unless you've got exactly the same stuff as myself. Another thing I want to point out is that anything I'm doing here is on a PC with Windows. I haven't got a clue about Mac, so if you have a Mac, I'm sure you're already used to finding your own alternatives. So, in order to upload the firmware, there's a few things we've got to do first. First of all, install and configure the Arduino IDE. What the hell is an Arduino IDE? Well, we'll look it up on Google, is it? It's simple enough. Link for this is in the description below again, and you simply download for your platform and open the thing up. Don't do the Windows app version. Once you've got that IDE open, then if we're using the ESP8266 to run the SmartWebServer, which I am, we're going to add support for that. So select File, Preferences, Additional Boards, Manager URLs, and add this address in there. You add support to your PC for this board from within the menu. Tools, Boards Manager. Use ESP8266 version 2.4.2. I think that's the one I used rather than 2.7.4. But I don't know. 2.7.4 may work better for you. If you're using the ESP32 as I am to run OnStep itself, or the Smart Hand controller, which I actually know nothing about, then you've got to go in and select File, Preferences, Additional Board Manager URLs, and add this address. So this is how it goes in. And then you install support for that. Same way as before, Menu, Tools, Boards Manager. Okay, that is the basics of the IDE configured. Now if you've followed what I've done so far, you've got to go back and check your work again. Remember, these instructions I'm working from are old. This video is only ever going to get older. So it's imperative to point out that this has got to be done in conjunction with the wiki pages. They are where the info is updated and the current best stable versions printed. So this is what you're going to have up in the background as you do this lot. These are the main instructions. Again, linked below. At the bottom of every wiki page is a little tab with pages. That's your little menu to get around the place. Have a good wander around, have a look. It's like the Bible as far as OnStep is concerned. Oh, there are also additional libraries available if you've got other stuff on your board. Your computer is now ready to flash the ESP32 and 8266 devices. Now we just need something to flash onto them. So, where do we go from here? Right, first off, there's a link here for the download of OnStep itself on GitHub. Once on GitHub, you go to the Code tab, and you do have a few options here, and I just tend to go with Download Zip. That'll go off to downloads, and we want to add to that the Configuration Calculator spreadsheet. Now this one I've already downloaded, and I've created a folder called OnStep, into which I've put the folder we've just downloaded, OnStep 424. It has been renamed just plain OnStep. Now in this OnStep folder, there's a bunch of different things that most of them you're not going to need. We're going to be messing with this one, config.h, and this one, onstep.ino. But not before the configuration calculator spreadsheet to calculate the mount-specific parameters. When you've got that file downloaded, you can't just open it with Word, it's an XLS file, and I had to download a program for that. I downloaded LibreOffice for that. It's fully free, and you just go through the usual install process, and then that can read the XLS file. The system will need a reboot after installing this. Now with this we're ready for the next step, but let's just check where we are with those original instructions. We've done this stage, install and configure the Arduino IDE. This means that we're ready to flash contents onto these boards. And we've done this step, getting the OnStep firmware. Now you'll see there's more information on the additional RTC libraries in here. I didn't go through this, because I don't want this video to be hours long. I did use one of these, I have an RTC clock. So here's the information, and you know where to find it. The only purpose of this video is just to put pictures to words to help you understand what you're reading. That's it. So you're following the instructions and using the video, rather than the other way around. So onto the preliminary firmware configuration. So it says here, we should start with the configuration calculator spreadsheet. And instead of editing the config.h file manually, you can use a web-based online configuration generator to get a basic working configuration fast. So let's first of all have a look at config.h. It's simply just a notepad file with a whole heap of gobbledygook in it. You could indeed edit this manually if you knew what you were doing, but these other tools are in place to make life easier. So this is the OnStep configuration calculator, open in LibreOffice. And these green boxes are the ones we need to fill in information on. So first of all, stepper steps. This refers to your motors. Mine are 0.9 degree 400 step motors, so it says 400 in there. Axis 1 and Axis 2 driver micro steps. I've put 32 steps in there, as a fairly safe bet. I believe the drivers are capable of up to 256, but I'm just going the easy route. GR1 ratio. Now this refers to the gear reduction 1 ratio, which is referring to the pulley wheels and belt. I forget which way around mine are, but if they're both 3, you get this, and if you change one of them to a ratio of 4:1, you just put in the figure 4, and it'll change the steps per degree on the left. And that's the figure we're going to take over to config.h. Now the GR2 ratio, that refers to the fact that for one full rotation of the RA axis, you would require 144 full turns of the slow rotation knob. And the same on the deck axis. This is a standard figure for EQ5 mounts. I'm not sure about others, you'd have to look into it. You also got slew rate base desired. That starts off at 2.5. I think I put 2 in mine because I wasn't looking for mine to do anything special. And I don't mind waiting like 30 seconds for it to find a target. It's nothing. It slews fast enough for me. I don't know why people want fast slewing scopes. So that's that calculator, and it's basically just going to come up with those figures for you. We can then go into the online configuration generator, where we input these. Now at the top, we've got OnStep version, 4 point something. That's what I'm using, 4.2.4. Mount type is equatorial, and the board, I'm using the Maxi SP3, so I select that from this drop down. Desired slewing rate, you can put what you like really, but as I've said, I've put 2 in mine. Maybe 1.5, I don't remember really. Steps per worm wheel rotation. Axis 1 steps per worm rot from the spreadsheet. That goes in this box. Now the axis 1 stepper motor, we want motor steps per rotation. So axis 1 and axis 2 on the right, I'm going to change this to 400 steps. The micro steps then, in the drop down below, I'm putting to 32. And I believe most of these other things are left in their standard state. But just a touch further down, we've got stepper driver model, and that's set for something totally different. I'm using the TMC 2130. And I believe on mine, I've actually got the 2130 quiet. I've actually selected that, and it does make a difference. It does make them run quietly. And I've noticed no drop off in performance for that. Again, read into it. That's pretty much it really. Once you're at the bottom of the page then, you can hit generate, and that will generate a config.h file. You then overwrite the config.h file in your OnStep folder. That's OnStep 424 that you renamed just OnStep. That then is ready to upload. So we're now ready to flash OnStep onto the ESP32 module. But we also have an ESP8266 here, and we need something to flash onto that. That's going to be the SmartWebServer, SWS. You can find it here on WIKI, and this WIKI page says about the steps we've taken already to get the IDE ready for this. Additional libraries if you're using Ethernet. Download it, just the same way we did with OnStep. Opening the smartwebserver.ini file in the IDE, you have to check the config.h file. Now as far as I remember, I think it was all set pretty well in the first place. I don't think I changed anything on mine. But again, have a read through, see what you're in need of, and see if you need to change anything. But it should, for most people, just be ready to go. And if it is, and you're happy with that, then we may as well flash the 8266 while we're here. So how do we do that? For this board, it's best to remove it from your OnStep build. So it's just the board, and you'll see there is a micro USB port on that. Take a good micro USB data cable, not a charging cable, and plug it into one of your computer ports. Now I know at this stage I had trouble with it not finding the port. And I think I took a couple of days trying to work it out. It was something to do with UART, USB controllers or something or other. I had to download a different set of drivers, and I don't even remember what they are. But if you search ports not showing up, you'll be led down the path I was led to fix that problem. But in most cases, you should just find that pops up, and at the top of the IDE then, in the Ports tab, you should see whatever port is actually active. I know on mine it was like COM5, it could be COM anything, and it doesn't matter. Depends on the port you've plugged into. Now, also in the menu at the top, you've got Tools, and then go to Board, and find the device you're flashing to. For the 8266, we're going to pick Lowlin, Wemos, D1, R2, and Mini. There are other options here on WIKI if you're using other boards. So we've got the board and port selected, and then up in the menu we've got Sketch. It says here pick Upload to send SmartWebServer firmware to the board, and basically that just does it by itself. It will compile, check and upload, all being well. If there's something wrong in your config.h file, then it'll tell you at the bottom of this IDE screen. But if it says complete 100%, then you're good to go. You can unplug that device and close out the IDE. So now we've got to do the same thing to flash OnStep itself onto the ESP32. This doesn't need removing from the controller. So you take your micro USB and plug this into your PC as before, and the 5V feed from that will power up the board. It's imperative that nothing else, like there's no motors plugged in or powered up at this stage, just the controller itself, and the USB is the only thing that should be connected to it. Now, in your OnStep folder, we're going to double click to launch OnStep.ino. And this opens up OnStep in the Arduino IDE. Once that's open, you can go along to the config.h tab and check through, make sure everything's looking good the way you did it. And just like before, we want to be correctly connected to the port and the ESP32 dev module. Now if we go to the Sketch tab, I usually like to click on Verify/compile. And that'll basically compile the sketch ready for flash, but it'll throw up any errors at you if you have made a mistake in the config.h before you try. All going well with that, then you can certainly click on Upload. And that should just upload straight onto that ESP32. And I've done this many times in trying to sort out problems in the past. And on some different makes of boards, it'll just continue looking for the board and not upload a thing until you press the little button on the side of the board there. I think there are two buttons, and I don't even remember which one, but neither can do any harm. That should then connect and you see the progress going up, how many percent uploaded. So if you've got a successful flash of your sketch from those steps, it says complete 100%, then down the bottom you have a little bar that says output, and in that you can type :GVP#. Hit enter, and it should return OnStep as an answer. And that's just basically OnStep saying, yep, I'm here, and it's successfully flashed to your board. From time to time, the flash just won't work. And this could be a faulty board. That has been known to happen, even when new. But it could be that the company that made these have sourced the flash boards from different sources. So you might try looking in this menu and you've got different flash modes. Try them. If one fails, another might work. And no one at OnStep has a definitive answer on which is best. It's down to the individual board. So if at this stage everything's looking good, you can close down this IDE and unplug the board. Plug your ESP8266 back onto your board once it's all powered down, and then you're ready. That is ready to go. But we can't go plugging in drivers yet because we've yet to do the stepper driver adjustment. Alright then. When it comes to adjusting the stepper motor drivers, this had me confused like hell for so long. But it is fairly straightforward. I'll go through basically what's on the page here. First of all, starts with a heat warning. These things do get very hot in use, and we don't want to be running them at their max rating because that might be too hot. We want to be running our stepper drivers somewhere between 30 and 70% of their maximum rating. Mine are 1.7 amp drivers, and I've chosen, just to make it easy, I'm going to go for a 1 amp output. This all depends on your motors and your stepper motor drivers, so make sure you get the specs up and you know the figures involved. So then there's various other warnings, there's info on different stepper drivers, and then a link to the WaterRot FAQ, which is very handy for working out what voltage we're going to need. There's also, at the very top of the page, a video link to the Pololu website, where it's very simply explained and showed. So, as I said, it is quite an easy process, and the instructions for adjusting the drivers down here start with assembling the OnStep controller. We've done that. You do not attach stepper motors to these drivers. Have nothing plugged in there. And at any time when the thing is powered on, you don't attach the motors. So once it's all sorted, you've got your power supply and you can safely power up your controller, do so. And then we can take a reading from these drivers and see what they're outputting. Basically, we take a multimeter set to the right voltage range. The one I'm using, I've put in the 2 volt DC range. And then you simply take a reading by putting the black probe, or the negative probe, onto the ground pin of the stepper driver, and the red probe goes onto the trim pot, and that'll give you a reading in voltage. Now, what voltage do we want? This is where the WaterRot FAQ comes into play. On this page is a handy little calculator, and I'm using the calculator for the TMC21 somethings. So I'm looking for a 1 amp current. So if I input 1 in that box there, and then click calculate, the voltage comes up as 1.41 volts. So that's what I'm going to look for on this. And to adjust up or down, we just need very slight movements with a little jeweler's screwdriver to this trim pot adjuster. And I believe anti-clockwise actually turns it up, strangely. And you only want to go a very slight amount to make a big difference. And it's quite hard to settle on an exact figure. And I'm not actually doing mine because it took me ages to get them pretty much exactly paired up. I'm just showing how you do this. Once you get the desired voltage on that reading on your multimeter, your stepper motor drivers are now ready to go. So you can close up your box and away you go. There wasn't much to that one, was there? But I wish someone had explained all that to me when I was looking at this. I was looking at it for days and it blew my head. I couldn't work it out. And luckily, everything works just fine. I mean, I might have needed a little more power and I'd have had to just experiment because I don't understand what they're telling me on these pages. Right, I think that concludes this video. We have downloaded the softwares for OnStep and the SmartWebServer. We've uploaded them onto, or flashed them onto the respective boards and adjusted the stepper motor drivers. And I was trying to keep this video short. I hope this helps. I hope none of it gets you into trouble. And it's your fault if it does, because remember, all these figures I've given are the ones I used last year. So check with WIKI. And if at any point there's something you really don't know, it doesn't make sense to you on WIKI, join the OnStep IO groups. You can post a question and there's a big old community that will answer. Yeah, the guy that created OnStep in the first place, the guy that sold me the kit, they're all there. There's other people that make videos on YouTube. These are the people that answer. So there's always help on hand. And on that note, I'm going to love you and leave you. So thanks for watching. Thanks for your likes and subscriptions and comments on all my videos so far. And if you haven't subscribed, why the hell not? There's more of this, well, there's not more of this coming. There's more better stuff coming. So, thank you again. Until next time, this is Cheapass-tro.